Hello, calculus fans. We're going to talk about quadric surfaces. The graph of a second-degree equation in three variables is called a quadric surface. This is going to be an analog to conic sections. In two-dimensional space, you deal with things like parabolas, hyperbolas, ellipses. Now we're going to expand these to three-dimensional figures. Now there are 6 types of quadric surfaces. There's ellipsoids, cones, elliptic paraboloids, hyperbolic paraboloids, and hyperboloids. And the hyperboloids come in 2 types, hyperboloids of 1 sheet and hyperboloids of 2 sheets. On the class website is a link to a file about quadric surfaces that shows you pictures of all of these things. Okay, so as an example, let's classify this surface. Negative x squared plus 6x minus y squared plus z squared plus 4z minus 4 equals 0. And it will be helpful if you have the quadric surface guide next to you while you're working through this problem. The first thing is that this is going to be a hyperboloid. And that's because there are x squared, y squared, and z squared terms, and there's 2 pluses and 1 minus. Now, usually when there's 1 minus sign, you get a hyperboloid of 1 sheet. But what I'd like to do is carry out the calculations just to make sure. So let's complete the square. So we start with our equation. We'll just do a little bit of manipulation. For instance, over here we pull out a minus sign. And now we're going to complete the square. So, what do we do here? We start with the negative 6, divide by 2, and square it. So we take negative 6, divide by 2, we get negative 3, square that to get 9. And we have to compensate that by putting a minus 9 on the other side. And you might be tempted to think, wait a minute, aren't we supposed to put the same thing on both sides? Well, in fact we are, because this minus sign here, if you distribute it, will give you a minus 9. So we didn't actually put a plus 9 on the left side, we actually put a minus 9. And so we compensate that by putting a minus 9 on the other side. Then the other one is a little bit easier. Take this number, divide by 2, and then square it, and that's how we end up with a 4. And then we have to put the 4 on both sides. And we put everything together, so this is why we added these numbers, so that we get perfect squares, and this is the equation that we get. Now we can't actually stop because of the minus sign on the right-hand side. If you go look at the list of quadric surfaces, they're all going to have a 1 on the right side. So we'll multiply both sides by negative 1, and now we'll get this equation. At this point, we can say that because there are 2 minus signs, this is going to be a hyperboloid of 2 sheets. It's going to be centered at 3, 0, negative 2, and the hyperboloid opens in the x direction. Okay, that's all for now.